Hello everyone, today we are going to talk about the minimum propagation zone. Today, we'll cover two key topics to explain the concepts in this lecture. First, we will discuss the power density for superconductor composite. Next, we will explain about the minimum propagation zone, the MPZ. This page contains parameters commonly used in Chapter 5. In the power density equation that describes thermal stability, storage refers to the rate of change of thermal energy density within a conductor over time. Conduction refers to the heat transferred through the conductor via conduction. Joule heating means heat generated by electrical resistance within the conductor when current flows through it. Disturbance means additional heat generated from sources other than Joule heating. Cooling represents the heat removed from the conductor by the process of convection cooling. Building on our understanding of the power density equation, let's now shift our focus to today's main topic, the minimum propagation zone, MPZ. MPZ represents the maximum size of a hot spot that a superconducting magnet can withstand if a hot spot suddenly appears within it. The calculation of MPZ is based on several assumptions. First, the magnet is assumed to be in an adiabatic condition, meaning there is no heat exchange with the environment. Second, it is assumed that the radius of the winding is much larger than the radius of the normal zone. This simplifies the geometry and the calculations related to heat distribution. Third, the thermal conductivity and electrical resistance of the winding are assumed to be uniform and do not change with temperature. Under these assumptions, we can also simplify the model by ignoring the storage, disturbance, and cooling terms in the power density equation. By applying the previously mentioned assumptions to the power density equation, we can derive the following formula. Ultimately, the MPZ is defined as shown here, and by substituting simple parameters on the right, we can calculate it as a single value. You can also calculate using these example parameters. The value calculated in this way can also be used as a basic reference in the design of magnets. In summary, the MPZ, minimum propagation zone, refers to the maximum size that a local hot spot can reach in a superconducting wire without propagating further. This calculation is crucial as a reference that superconductors can withstand localized heating without losing their superconducting properties.